Question 1. An amount of $2,500 is invested at a simple interest rate of 3% per annum. How much interest is earned in the first 2 years? The question is asking for the amount of simple interest earned on the investment. So we'll need to use the simple interest formula, I equals P times R times N, where I represents the amount of interest earned, P, which represents the principal or the amount invested, R represents the simple interest rate per period, and N represents the number of periods that the investment runs for. Now in this case, the principal is $2,500, R is 3% per annum or per year, and N represents the number of years that this investment runs for, which in this case is 2 years, so N will equal 2. So substituting those three values for P, R, and N respectively, we get I, or the interest, is equal to 2,500 times 3% times 2, which equals $150. Therefore, the correct answer is option B. Question 2. In a normal distribution, what is the approximate percentage of scores with a z-score less than 1? We can use the empirical rule to estimate the percentage of scores with a z-score less than 1. The empirical rule is also known as the 68%, 95%, 99.7% rule. That rule states that approximately 68% of scores will lie between a z-score of -1 and +1. That same rule also states that approximately 95% of scores will lie between a z-score of -2 and +2, and so on. The question, though, is asking for the approximate percentage of scores with a z-score less than 1. So here's a z-score of 1 that's noted on this sketch of the normal distribution. We want the percentage of scores that lie to the left of 1, so that's this area here. We know that 50% of scores must lie below a z-score of 0. And if 68% of scores lie between a z-score of -1 and +1, and the normal distribution is symmetrical, that means 34% of scores must lie between a z-score of 0 and +1. So to find the percentage of scores with a z-score less than 1, we take 50%, so that's the percentage of scores that lie below a z-score of 0, add on to that 34%, and we get 84%. Therefore, the correct answer is option C. Question 3. The number of bees leaving a hive was observed and recorded over 14 days at different times of the day. Which Pearson's correlation coefficient best describes the observations? To help visualize the strength and the direction of the correlation between the number of bees and the time of day, I'm going to draw a line of fit by eye through the points on this scatter plot. I'm going to draw this line of fit in such a way so as to minimize the average distance as best as possible between all the points and the line of fit itself. So roughly half the points should be above the line and half the points should be below the line. And the distance between each of these points and the line itself should be as small as possible. Now it's not a line of best fit, it's just a line of fit. And it's done by eye, so it's not going to be 100% accurate. But it can be close enough in order to give us a visual reference to the direction and the strength of the correlation. Now, looking at this line of fit, we can see that we have a positive correlation since it has a positive gradient between the number of bees and the time of day. And looking at the distance between the points and the line itself, we can see that the points are reasonably close to the line, which indicates a reasonably strong correlation. So we have a strong positive correlation between the number of bees and the time of day as indicated by this line of fit and the closeness of the points to this line of fit. Looking at the responses, the best response will be option D, 0.8. Question 4. A delivery truck was valued at $65,000 when new. The value of the truck depreciates at a rate of 22 cents per kilometre travelled. What is the value of the truck after it has travelled a total distance of 132,600 kilometres? The first thing to notice after reading the question is that the truck is valued in dollars, but the depreciation rate is quoted in cents per kilometre travelled. Now the question is asking for the value of the truck in dollars after it has travelled a total distance of 132,600 kilometres. In order for the solution to be valid, all currency values need to be in dollars, and that includes the depreciation rate of 22 cents per kilometre travelled. So my first step is to convert this depreciation rate into dollars per kilometre travelled. So to convert cents into dollars, we divide 22 by 100 and we get 0.22. So 22 cents is equivalent to $0.22. The next step is to find the amount of depreciation, which represents the loss in value of the truck after it has travelled 132,600 kilometres. Now we know that the truck loses $0.22 per kilometre travelled. So to find the amount of depreciation over this distance, we take the distance travelled, which is 132,600, and we multiply that by the depreciation rate in dollars per kilometre. So 132,600 times 0.22 equals $29,172. The last step is to find the salvage or the current value of the truck when depreciation is taken into account. And that is given by the value of the truck when new, which is $65,000, take away the amount of depreciation that we found in this step here, which is $29,172, and we get $35,828. Therefore, the correct answer is option A. Question 5. 4 petrol pumps are shown, each with the amount of petrol purchased and its cost. Which one represents the best value? One way to work out the best value is to work out the cost per litre for each of the 4 options. The one with the lowest cost per litre represents the best value. To work out the cost per litre, we take the total amount spent and divide that by the number of litres purchased. So let's consider option A. $46.70 was spent to buy 24 litres of petrol. So to get the cost per litre, we take this value here, $46.70, and then divide that by the number of litres purchased, which is 24. And that gives us $1.95 per litre, correct to the nearest cent. Let's consider option B. $48.50 was spent to buy 25 litres of petrol. To get the cost per litre, we do $48.50, divide that by 25, we get $1.94 per litre. So at this stage, option B represents the best value. Let's consider option C. $52.30 divided by 26 gives us $2.01 per litre. And considering option D, $54.80, divide that by 27 and we get $2.03 per litre. So option B represents the best value for money at $1.94 per litre. Question 6. An item was purchased for a price of $880, including 10% GST. What is the amount of GST included in the price? Since this price includes 10% GST, $880 represents 110% of the item's value. So that's 100%, which is the item's value, plus 10% GST, and that gives us the 110%. Now we can use the unitary method to work out the value of 1% and then multiply that by 10 to get the value of 10%, which represents the 10% GST. So starting with the price of $880, dividing that by 110 to get the value of 1%, and then multiplying that by 10 to get the value of 10%, and we can do that all in one step, we get $80. Therefore, the correct answer is option C. Question 7. City A is at a latitude of 34 degrees south and longitude 151 degrees east. City B is 72 degrees north of City A and 25 degrees west of City A. What are the latitude and longitude of City B? One way to work this out is to represent the compass directions as either positive or negative. We'll consider north and east as positive directions, south and west as negative directions. Now we're given the coordinates of City A. It has a latitude of 34 degrees south, which we can write as negative 34 degrees, and a longitude of 151 degrees east, which we can write as positive 151 degrees. Now we're given how far to the north and west that City B is relative to City A. So let's work out the latitude of City B. We're going to start with negative 34 degrees, since that's our reference latitude, and we're given that City B is 72 degrees north of City A. So to get the latitude of City B, we start off with negative 34 degrees and we're going to add on 72 degrees, and we get positive 38 degrees, which we'll interpret as north, since it's a positive number. To get the longitude of City B, we start off with 151 degrees, so positive 151 degrees, and we take away 25 degrees, since City B is to the west of City A. And we get positive 126 degrees, which we'll interpret as east. Therefore, the coordinates of City B is 38 degrees north, 126 degrees east. Therefore, the correct answer is option C. Question 8. A game involves throwing a die and spinning a spinner. The sum of the two numbers obtained is the score. The table of scores below is partially completed. What is the probability of getting a score of 7 or more? The question is asking for the probability of getting a score of 7 or more. Now, out of the 24 cells in the two-way table, we're only interested in the cells that contain the number 7 or greater. Now, to get the number in the cell, we take the number on the die and add it to the number on the spinner. So in this case, we can get 7 here by getting 6 on the die and adding it to 1 on the spinner to give us 7. Now, there are 4 ways of scoring a total of 7. There are 3 ways of scoring a total of 8. There are 2 ways of scoring a total of 9, and there's only 1 way of scoring a total of 10. So out of the 24 cells, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of those 24 contain the number 7 or more. So the probability of scoring 7 or more is equal to 10, which are our favoured outcomes, over 24, which are the total number of outcomes. And 10 over 24 simplifies to 5 over 12. Therefore, the correct answer is option D. Question 9. The length and width of a rectangle are measured to be 8 centimeters and 5 centimeters respectively, to the nearest centimeter. What are the lower and upper bounds for the area of the rectangle? Since the dimensions of the rectangle are quoted to the nearest centimeter, the actual length could be between 7.5 centimeters and 8.5 centimeters, and the actual width could be between 4.5 centimeters and 5.5 centimeters. To get the lower limit or the lower bound for the area of the rectangle, we take the lower limit for the length and multiply it by the lower limit for the width to give us the lower bound for the area of the rectangle. So 7.5 times 4.5 gives us 33.75 square centimeters. Now, if we consider the four options, only one of those options shows 33.75 square centimeters, which is option D. So we know at this stage, option D has to be correct. But just for completeness, let's work out the upper limit or the upper bound for the area of this rectangle. So we take the upper limit for the length, which is 8.5 centimeters, multiply it by the upper limit for the width, which is 5.5 centimeters. 8.5 times 5.5 gives us 46.75 square centimeters. Therefore, the correct answer is option D. Question 10. An amount of $25,000 is invested for 6 years. Interest is earned at a rate of 8% per annum, compounded quarterly. Which expression gives the value of the investment after 6 years in dollars? The first thing we need to work out is the interest rate per period. Now, the interest rate is quoted as 8% per annum, but it's compounded quarterly. So the length of one period is 1 quarter or 3 months of a year, and there are 4 quarters in 1 year. So the interest rate per quarter is found by 8% per annum divided by 4 quarters per year, which gives us 2% per quarter. The next thing we need to work out is the total number of compounding periods. There are 4 quarters in 1 year, and the amount of $25,000 is invested for a total of 6 years. So the total number of compounding periods is 4 times 6, which is equal to 24. So using the future value formula, the future value of $25,000 invested for 6 years is given by 25,000 times 1 plus 2% in brackets to the power of 24. So that's 1 plus the interest rate per period in brackets to the power of the total number of compounding periods, which is 24. Now, 1 plus 2% is equivalent to 1.02 in decimal. So the future value is given by 25,000 times 1.02 to the power of 24. Therefore, the correct answer is option A. Question 11. A bag contains 150 jelly beans. Some of them are red and the rest are blue. The ratio of red to blue jelly beans is 2 to 3. Sophie eats 10 of each colour. What is the new ratio of red to blue jelly beans? The first thing I want to work out is the actual number of red jelly beans in the jar. Now we know there are 150 jelly beans in the jar. And we know that for every 2 red jelly beans, there are 3 blue jelly beans. So I can apply the unitary method to work out the actual number of red jelly beans in the jar by working out the value of 1 part or 1 share. So if we look at the terms of the ratio, we have a 2 and a 3. If we add those two together, we get 5 parts. So to find the value of 1 part, we take 150 jelly beans and we divide it by 5. So that's applying the unitary method. And we know that 2 of those parts or 2 of those shares are red jelly beans. So 150 divided by 5 times 2 gives us 60. So there are 60 red jelly beans in the jar. So to get the number of blue jelly beans, that's the difference between the total number of jelly beans, so that's 150, and the number of red jelly beans that we just found, which is 60. So 150 minus 60 gives us 90 blue jelly beans. So to work out the new ratio, we know that Sophie eats 10 of each colour. So we have 50 red jelly beans to 80 blue jelly beans. So we subtract 10 from each of these values. So the new ratio is 50 to 80. So that's the ratio of red jelly beans to blue jelly beans after Sophie eats 10 of each colour. And dividing each of these terms by 10 to simplify it, we get 5 to 8, which is our new ratio. Therefore, the correct answer is option C. Question 12. A cylindrical pipe with a radius of 12.5 centimetres is filled with water to a depth, d centimetres, as shown. The surface of the water has a width of 20 centimetres. What is the depth of water in the pipe? Let's analyse this diagram. The question is asking for the value of d, which represents the depth of water in the pipe. Now we do know that the radius of this pipe, or the circle, is 12.5 centimetres. And that's the distance from the centre of the circle to any point on the circumference of this circle. So that means that the distance from the centre of the circle to this point here, right underneath this point, going through the short side of this right angle triangle, is also 12.5 centimetres. That means the difference between the radius of the circle and the length of the short side of this right angle triangle will equal d centimetres, which is the depth of water in this pipe. So if we can work out the length of the short side of this right angle triangle, subtract that from 12.5 centimetres, we've found the depth of water in this pipe. Now we also know that the surface of the water, the width of the surface of the water is 20 centimetres and it's been split in half. And that's the meaning of the double dashes here and here. So we know that the hypotenuse of this right angle triangle is 12.5 centimetres. We also know that the other short side has length 10 centimetres, which is half of 20 centimetres. So we can apply Pythagoras' theorem to find the length of the short side that we're interested in, which I've marked with the variable x. So applying Pythagoras' theorem, and in particular the subtraction version of Pythagoras' theorem, since we're trying to find the length of a short side, we have x squared is equal to 12.5 squared minus 10 squared. And 12.5 squared minus 10 squared evaluates to 56.25. So we have x squared is equal to 56.25, but we want the value of x, not x squared. So we need to take the square root of 56.25 to get the value of x, which is the length of this short side. And the square root of 56.25 is 7.5 centimetres. So finally, to find the depth of water in this pipe, which is represented by the variable d, we take the radius of the circle, so that's the distance from here to here, 12.5 centimetres, and we subtract from that the length of the short side of this right angle triangle that we just found, which is 7.5 centimetres, and that equals 5.0 centimetres. Therefore, the correct answer is option B. Question 13. An item is discounted by 30% and then a further discount of 20% is applied to the reduced price. What is the total percentage discount? The question is asking for the total percentage discount, which is a single percentage that is equivalent to discounting an item by 30% and then later discounting it by another 20% on the already reduced price. Now, since we don't know what the original selling price of the item was, and the question is asking for a percentage discount, we can use whatever value we want for the original selling price in order to work out the percentage discount, since it doesn't matter what the original selling price was. And a good number to work with is 100. So assuming that the original selling price of the item is $100, and then discounting it by 30%, which is equivalent to multiplying this value here by 70%, and then discounting it another 20%. So we're going to multiply what we've got here by 80%, we end up with $56. So in other words, starting off with $100, discounting it by 30%, discounting the already discounted price by another 20%, the item is now selling for $56. So the discount is the difference between the original selling price and the final selling price. So $100 minus $56 is equal to $44. And since we started with an original selling price of $100, we can interpret this number here, $44, as the actual percentage discount of 44%, which is why I like to use $100 to begin with. But for completeness, if we wanted to work out the percentage discount using a formula, we take the actual discount we just found, which is $44, divide it by the original selling price of $100, and then multiplying that by 100 to convert it to a percentage, we get 44%. Therefore, the correct answer is option B. Question 14. A network with source A and sink B is shown. The capacities of two paths are labelled. The cut shown on the diagram has a capacity of 30. Which of the following statements is correct? If we compare the value of the cut to the value of the flow into sink B, the value of the cut is 30. The value of the flow into sink B is 20 plus 15, which equals 35. And the cut represents the maximum flow through the network through that particular cut. Now, since the value of this cut is 30 and it's less than 35, we know for a fact that the maximum flow is not 35. Therefore, option B is incorrect. Going back to the cut, we're not told whether it's the minimum cut or not. Now, if this was the minimum cut, this would represent the maximum flow. Therefore, the maximum flow in that case would be 30. But since we're not told whether this is the minimum cut or not, there may exist a cut somewhere else on the network with a lower capacity than 30. Let's say, for argument's sake, 25. That would mean then that this value here, 30, will represent the absolute maximum that this network can flow. And since there is a possibility that there may be a cut of lower value than 30, that would mean that the maximum flow of this entire network can be no more than 30. In other words, it'd have to be 30 or less. Therefore, the correct answer is option C. Question 15. Ashan's mathematics class needs to complete 6 tests, each worth 100 marks. After completing the first 5 tests, Ashan calculated that he would need a mark of 90 in the final test in order to have a mean mark of 80 for the 6 tests. What was Ashan's mean mark after completing the first 5 tests? The strategy I'm going to use is to consider the sum of marks over the 6 tests taken, and then find the sum of the marks over the first 5 tests taken in order to work out Ashan's mean mark for the first 5 tests. Now we know that Ashan calculated that he would need a mark of 90 in the final test, in other words, the 6th test, in order to have a mean mark of 80 over all 6 tests. So if Ashan's mean mark is 80 over the 6 tests, and if we multiply 80 times 6, that implies that the total number of marks gained over the 6 tests is 480. Now Ashan calculated that the final mark will need to be 90. That means that the sum of the marks in the first 5 tests plus 90 is equal to 480 marks gained. So to work out the sum of the first 5 tests, we take 480 and subtract 90 from that, which means that the sum of the marks in the first 5 tests is 390. So in order to work out the average mark or the mean mark in each of those 5 tests, we take the total marks gained over the 5 tests and then divide it by 5 to get the mean mark per test in the first 5 tests. So 390 divided by 5 is equal to 78. So Ashan's mean mark after completing the first 5 tests is 78. Therefore, the correct answer is option A. Question 16. The graph shows Peter's heart rate in beats per minute during the first 60 minutes of a marathon. Part A. What was Peter's heart rate 20 minutes after she started her marathon? The number of minutes since Peter started her marathon are indicated using the numbers on the x-axis. So to find Peter's heart rate 20 minutes after she started her marathon, we'll locate 20 on the x-axis, we'll project up until we strike the curve, and then project across to the y-axis and read the value there. So at 20 minutes after she started her marathon, her heart rate will be 120 beats per minute. Part B. Peter started the marathon at 10 a.m. At what time would her heart rate first reach 140 beats per minute? It's given that Peter started the marathon at 10 a.m. So we want to find out how many minutes after 10 a.m. when her heart rate first reaches 140 beats per minute. So I'm going to go to the y-axis, locate 140 beats per minute, and then work out how many minutes past 10 a.m. when her heart rate first reaches 140 BPM. So starting with 140 on the y-axis, projecting across until we strike the curve, and then projecting directly down and reading the value that corresponds on the x-axis, we can see that 30 minutes after Peter started the marathon, her heart rate first reaches 140 beats per minute. So starting at 10 a.m. and 30 minutes later, that gives us a time of 10:30 a.m. Question 17. The table shows some of the flight distances, rounded to the nearest 10 kilometres, between various Australian cities. Part A. Use the information in the table to complete the network diagram where the edges are labelled with distances. Let's analyse this table. Any cell that contains a dash means there's no direct connection by plane between those two cities. So for example, this dash here indicates there's no direct flight between Adelaide and Brisbane. Any cell that contains a number or a value, for example, this cell here, 1170, indicates that there is a direct flight between Adelaide and Hobart, and the distance by plane between those two cities is 1,170 kilometres. Now we can use these values to then complete the network diagram by connecting the relevant vertices. Now each of these vertices represent the capital cities. So for example, P represents Perth, D represents Darwin, B represents Brisbane, S represents Sydney, H represents Hobart, and A represents Adelaide. So going back to the table, first thing I'm going to do is draw in the edges. So there's an edge between A and H. So going to our network diagram, locate A and H using a ruler. I'm going to join those two vertices like that. Then what I'm going to do is write the distance next to that edge. So 1170. Go back to the table. We have a connection between Adelaide and Perth, and the distance is 2120 kilometres. So I'm going to locate A and P and join those two together with an edge. And write the distance next to that edge, so 2120. This value here, 2850, there's a connection between Brisbane and Darwin. So I'm going to join those two vertices and write 2850. The completed network diagram should look something like this. So we have the relevant edges connecting the relevant vertices with the relevant values on each of those edges. Just make sure though to check that the edges are correct by comparing your network diagram with the values in the table. Part B. Marcia wants to travel from Hobart to Darwin. She wants to change planes only once. Using the network diagram, calculate how many kilometres she will travel by plane. Marcia wants to travel from Hobart to Darwin, but only wants to change planes once, which means there must only be one vertex in between Hobart and Darwin. So by inspection, the only path that Marcia could take is via Sydney. Any other way would mean that she'd have to change planes more than once. So from Hobart to Sydney to Darwin, we'll just write these values down. So there's 1,040 kilometres from Hobart to Sydney, plus 3,150 kilometres from Sydney to Darwin, and that gives us a total of 4,190 kilometres. Question 18. The histogram shows a summary of scores on a test. Provide two features of the histogram that indicate that the data comes from a normal distribution. In this sample solution, I've provided more than two features that indicate that the data come from a normal distribution. Any two out of the ones presented should be sufficient for 2 marks for this question. Now the first feature is that the histogram is symmetrical about the score 49.5, so it's neither negatively skewed or positively skewed. It roughly follows a bell-shaped curve. Now I've sketched a bell-shaped curve, or at least something that resembles a bell-shaped curve, on top of the histogram. The mode, mean and median are roughly equal around 49.5. It is unimodal, that is, there is only one mode. And most of the scores are concentrated around 49.5. Question 19. A network of running tracks connects the points A, B, C, D, E, F, G, H as shown. The number on each edge represents the time in minutes that a typical runner should take to run along each track. Part A. Which path could a typical runner take to run from point A to point D in the shortest time? By inspection, if we consider the various paths from point A to point D, we'll find that A, B, F, G, D represents the path of shortest time. And the time taken is found by adding the numbers on the edges on the highlighted path. So 3 plus 1 plus 5 plus 5 gives us 14 minutes. Part B. A spanning tree of the network above is shown. Is it a minimum spanning tree? Give a reason for your answer. Recall that a minimum spanning tree is a tree that connects all the vertices in such a way that there are no cycles. In other words, there's only one way to go from any one point to another. Also, the edges chosen should result in the tree of minimum weight. Now in this case, the spanning tree shown is not the minimum spanning tree, because if we remove edge BC and replace it with, say, edge CD or edge GC, it'll result in a tree or a spanning tree of less weight than the tree shown. So if we go back to the network diagram from part A, this is edge BC. If we remove this and replace it with edge CD or GC, these two edges are lower weight than edge BC. So that will result in a spanning tree of lower weight than the tree shown. So here is my explanation. I wrote no, removing edge BC, weight 11, and replacing it with edge CD, weight 9, or edge GC, weight 10, results in a tree of lower weight than the tree shown. Question 20. On another planet, a ball is launched vertically into the air from the ground. The height above the ground, h meters, can be modelled using the function h equals negative 6t squared plus 24t, where t is measured in seconds. The graph of the function is shown. Part A. Based on the graph, what is the maximum height reached by the ball? Let's analyse this graph. Firstly, it's a concave down parabola. We know this because the highest power of the independent variable t is a 2. Secondly, the t squared term is being multiplied by a negative number, negative 6, and that's what causes the graph to be concave down. Now the vertex, or the turning point of this parabola, represents the maximum height that the ball will reach. Now we can work out the maximum height of the ball in one of two ways. The first way is by inspection, locating the vertex and then projecting across to the y-axis, which represents the height of the ball at any particular time, and then reading the height directly on the y-axis, or the h-axis in this case. So locating the vertex and projecting across, this is the maximum height of the ball here, which is 24 meters. And we can count from 20 or count down from 25, 20, 21, 22, 23, 24 meters. So that's the maximum height that the ball will reach. The other way we can work this out is algebraically. We know that the maximum height of the ball is reached at time t equals 2 seconds, which is exactly halfway between when the ball is launched into the air at time t equals 0 and when the ball lands on the ground at time t equals 4. So the point halfway between 0 and 4, which is the average of 0 and 4, which is 2, substituting 2 into this equation for t and then evaluating negative 6 times 2 squared plus 24 times 2, we get 24 meters. And the answer is written here. Part B. Based on the graph, at what 2 times is the ball at 3/4 of its maximum height? The first thing we need to work out here is what is 3/4 of the maximum height that the ball will reach. Now, from part A, we worked out that the maximum height is 24 meters. So 3/4 of 24 meters, so that's 3/4 times 24 meters, is equal to 18 metres. So going back to the graph, locate 18 metres on the y-axis or the vertical axis. If we project across until we strike the parabola in these 2 points here, so at this point here and at this point here, and then project directly downward to read the time directly off the x-axis or the horizontal axis, at the first point or at the first time that the ball reaches 18 metres occurs at time 1 second after the ball is launched. And the second time that the ball reaches a height of 18 metres, so that's on the return, is at time 3 seconds after the ball is launched. So writing that down as our answer, the ball reaches a height of 18 metres at time 1 second and 3 seconds. Question 21. Electricity provider A charges 25 cents per kilowatt hour for electricity, plus a fixed monthly charge of $40. Part A. Complete the table showing provider A's monthly charges for different levels of electricity usage. The question is asking us to complete this table, and to complete this table we need to find the value that's in this box here. And that's the monthly charge in dollars for 400 kilowatt hours of usage in that month. Now, since the monthly charge is in dollars, but the charge per kilowatt hour is quoted in cents, the first thing we need to do is to convert this rate into dollars per kilowatt hour in order to keep the units of measurement consistent. So 25 cents per kilowatt hour, if we divide that by 100, that's $0.25 per kilowatt hour. To find this value here, so that's the monthly charge in dollars, we take the number of kilowatt hours used, which is 400, multiply that by the rate, so that's the dollars per kilowatt hour, that's 0.25, which is this value here, and then we add on the fixed monthly charge of $40. So 400 times 0.25 plus 40 is equal to 140. So the monthly charge in dollars for 400 kilowatt hours used is 140. Part B. On the grid on the previous page, graph provider A's charges from the table in Part A. To graph provider A's charges on the grid, we treat the columns in this table of values as coordinates. So the first row represents the x coordinates and the second row represents the corresponding y coordinates. So the 3 points we need to plot are 0, 40, 400, 140 and 1000, 290. So on the grid, there's 0, 40, there's 400, 140, and there's 1000, 290. So if this is done correctly, if we place a ruler against those 3 points should line up, and then just draw a line through those 3 points. Don't forget to label which line is which. Part C. Use the two graphs to determine the number of kilowatt hours per month for which provider A and provider B charge the same amount. The break-even point represents the point where both provider A and provider B charge exactly the same amount for the amount of electricity used in that month. And in this case, the break-even point occurs at 400 kilowatt hours per month. So the correct answer is 400 kilowatt hours per month. Part D. A customer uses an average of 800 kilowatt hours per month. Which provider, A or B, would be the cheaper option and by how much? From the graph, a customer that uses 800 kilowatt hours will be charged $240 using provider A and $280 using provider B. So firstly, provider A is cheaper. And by how much? Well, it's the gap between these 2 points. So 280 minus 240 is equal to $40. Writing that down as our solution. Here is a suggested solution. So from the graph, provider A is cheaper and the saving is equal to 280 minus 240, which equals $40. Question 22. The braking distance of a car in meters is directly proportional to the square of its speed in kilometers per hour and can be represented by the equation braking distance equals k times speed squared, where k is the constant of variation. The braking distance for a car travelling at 50 kilometers per hour is 20 meters. Part A. Find the value of k. We find the value of k by solving this equation, given that the braking distance is 20 meters at a speed of 50 kilometers per hour. So substituting those two values for the braking distance and the speed, we get 20 is equal to k times 50 squared. 50 squared is 2,500, so the equation becomes 20 equals k times 2,500. Now to make k the subject, we divide both sides of the equation by 2,500, since division is the opposite of multiplication. So 20 divided by 2,500 is equal to k, and 20 divided by 2,500 is equal to 0.008. Therefore, k equals 0.008. Part B. What is the braking distance when the speed of the car is 90 kilometers per hour? Using the value of k that we found in Part A, which is 0.008, to find the braking distance when the speed of the car is 90 kilometers an hour, we substitute 90 into this formula here and 0.008 for k here. So the braking distance is equal to 0.008 times 90 squared, and that evaluates to 64.8 meters. Question 23. 100 tickets are sold in a raffle which offers 2 prizes. Hazel buys 5 of the tickets. A ticket is drawn at random for the first prize. A second ticket is drawn from the remaining tickets for the other prize. What is the probability that Hazel wins both prizes? Let's consider the first draw. There are 100 tickets in the barrel, of which 5 are winning tickets. So the probability that Hazel will win on the first draw is 5 over 100. So let's assume Hazel wins on the first draw. 1 ticket has been removed from the barrel, so there are only 99 tickets left. And the ticket that was removed was one of the 5 winning tickets, so there are only 4 winning tickets left in the barrel out of 99. So the probability of a win on the second draw is 4 over 99. So to find the probability that Hazel wins on both draws, we use the multiplication rule of probability. And that's the probability of a win on the first draw, 5 over 100, multiplied by the probability of the win on the second draw, which is 4 over 99. And that gives us 1 over 495, which is approximately equal to 0.2%. Question 24. The diagram shows the cross-section of a wall across a creek. Part A. Use two applications of the trapezoidal rule to estimate the area of the cross-section of the wall. We can apply the extended trapezoidal rule formula to estimate the area of this irregular shape. Now we have three measurements, 1.9 meters, 2.7 meters, and 1.7 meters. And the distance between successive measurements is half of 8 meters, since we have two equal width sections, and that's 4.0 meters. And that's substituted for the pronumeral or the variable h in the trapezoidal rule formula. So the area of this irregular shape is approximately equal to h over 2 or 4 over 2 outside of one lot of this measurement, so that's 1.9 meters, plus two lots of this measurement, so that's 2 times 2.7 meters, plus one lot of this measurement, so that's plus 1.7 meters in brackets. And evaluating this expression, we get 18 square meters. Part B. The wall has a uniform thickness of 0.80 meters. The weight of 1 cubic meter of concrete is 3.52 tons. How many tons of concrete are in the wall? Give the answer to two significant figures. Now the wall has a uniform thickness of 0.80 meters. Now the key word here is uniform. That means that we're dealing with a shape that is a prism. And to find the volume of this prism, we can apply the volume of a prism formula. V equals the area of the cross-section multiplied by the height or depth, or in this case, the uniform thickness. And because we're dealing with an approximation to the cross-sectional area of this wall, I'm using the approximately equals to symbol here, the volume of the prism is approximately equal to 18, so that's the cross-sectional area, multiplied by the uniform thickness of 0.80 meters, and that gives us 14.4 cubic meters. Now the weight of concrete per cubic meter is 3.52 tons, and we have 14.4 cubic meters. So to get the weight or mass of concrete in this wall, we take the volume of the wall, which is 14.4 cubic meters, and we multiply that by the weight of concrete per cubic meter, which is 3.52. And that gives us approximately 50.688 tons. Now the question is asking us to give the answer correct to two significant figures. So rounding 50.688 correct to two significant figures, the 5 and the 0 are the two significant figures, and the 0 needs to be rounded up to 1 because the digit along is 5 or more, and that gives us 51 tons, correct to two significant figures. Question 25. A table of future value interest factors for an annuity of $1 is shown. Part A. Mickey wants to save $450,000 over the next 10 years. If the interest rate is 6% per annum compounding annually, how much should Mickey contribute each year? Give your answer to the nearest dollar. The first thing we need to find is the correct interest factor from the table. We know that the annuity is earning interest at 6% per annum, compounding annually. So there's no division of this interest rate required. So we can reference this column here. We know that the length of one period is 1 year and the investment runs over 10 years. So we need to reference this row here. So the intersection of this row and this column is this cell here, 13.181. So the interest factor is 13.181. Now to find the value of the yearly contribution, we take the future value, so this is what Mickey wants at the end of 10 years, and we divide it by the interest factor that we found previously. So we're dividing that by 13.181, and that gives us $34,140.05. Now, the question is asking us to give our answer correct to the nearest dollar. So rounding this value here to the nearest dollar, Mickey should contribute $34,140 each year. Part B. Instead, Mickey decides to contribute $8,535 every 3 months for 10 years to an annuity paying 6% per annum, compounding quarterly. How much will Mickey have at the end of 10 years? The first thing we need to find is the correct interest factor from the table. So that's similar to what we did in Part A. However, the situation has now changed. Instead of the contribution being done annually or yearly, it's now every 3 months or every quarter, and it's compounding quarterly. So we need to find the interest rate per quarter. Now it's still 6% per annum, but to get the interest rate per quarter, we need to divide that interest rate by 4. So 6% divided by 4 gives us 1.5% per quarter. Now the total number of compounding periods is given by 4 compounding periods per year, since there are 4 quarters in 1 year, and we multiply that by 10 years to give us a total of 40 compounding periods. Going back to the table, we reference this column here, 1.5% per quarter, over a period of 40 quarters. And this is our interest factor, 54.268. And I've written that here. So to find the future value, which is the amount that Mickey will have at the end of 10 years, we take Mickey's contribution of $8,535 and we multiply that by the interest factor that we just found, 54.268. And that gives us $463,177.38. Therefore, Mickey will have $463,177.38 at the end of 10 years. Question 26. Kim is building a path around a garden at the back of a house as shown. The path is 0.5 meters wide. Part A. Find the area of the path. The area of the path is the difference between the area of the large rectangle and the area of the small rectangle which represents the garden. Now the dimensions of the large rectangle is 3 meters by 8 meters. The dimensions of the garden, when taking into account the width of the path, so subtracting the width of the path from the dimensions of the large rectangle, that gives us the dimensions of the garden 2.5 meters by 7 meters. So the difference between these two areas, the area of the large rectangle and the area of the small rectangle, will give us the area of the path. So showing that here, as part of the solution, we have path area is equal to 3 times 8, which is the area of the large rectangle, minus 2.5 times 7, which is the area of the small rectangle, and that equals 6.5. Therefore, the area of the path is 6.5 square meters. Part B. Kim is mixing some concrete for the path. The concrete mix is made up of crushed rock, sand, and cement in the ratio of 4 to 2 to 1 by weight. Kim needs 2.1 tonnes of concrete mix in the correct ratio. Calculate how many 15 kilogram bags of cement Kim needs to buy. Working backwards, the question is asking for how many 15 kilogram bags of cement are needed to make 2.1 tonnes of concrete mix. So our first issue are these different units of measure for weight or mass. So the first thing I did was to convert 2.1 tonnes into kilograms. That way I'm comparing kilograms with kilograms. The next step is to find out the number of parts in this ratio. So we have the ratio here, 4 to 2 to 1, which is rock to sand to cement. So 4 plus 2 plus 1 gives us 7 parts, and those 7 parts has a weight of 2,100 kilograms. So we need to find the weight of one part in this ratio. And we do that by taking the total weight, dividing that by the total number of parts in this ratio. So 2,100 divided by 7 gives us 300 kilograms. And it just so happens that one part in this ratio represents the amount of cement or the weight of cement needed. So 300 kilograms of cement are required. So to find the number of cement bags needed, given that each bag is 15 kilograms in weight, we take the total weight of cement needed, divide that by the weight per bag. So 300 divided by 15 equals 20. So therefore 20 cement bags are needed for this concrete mix. Question 27. The diagram shows the location of 3 places, X, Y, and C. Y is on a bearing of 120 degrees and 15 kilometers from X. C is 40 kilometers from X and lies due west of Y. P lies on the line joining C and Y and is due south of X. Part A. Find the distance from X to P. The question is asking for this distance here, XP, and that's the side of this particular right angle triangle, XPY. Now it's given that the bearing of Y from X is 120 degrees. And this angle here must be 60 degrees since 2 adjacent angles on a straight line are supplementary or add up to 180 degrees. So now we have a right angle triangle where the hypotenuse is known, it's 15 kilometers, and we have a known angle. So we can apply regular right angle trigonometry or SOHCAHTOA to work out the length of this side here, which represents distance XP. So this is our angle. This is the adjacent side. This is the hypotenuse. So using SOHCAHTOA, we need to apply the cosine trigonometric ratio. So adjacent divided by hypotenuse, or adjacent over hypotenuse, is equal to cos theta. So XP divided by 15 is equal to cos 60 degrees. Multiplying both sides of this equation by 15 to make XP the subject, we get XP is equal to cos 60 degrees times 15, which equals 7.5. Therefore, the distance from X to P is 7.5 kilometers. Part B. What is the bearing of C from X to the nearest degree? To find the bearing of C from X, we need to focus on this triangle here, triangle XPC. And it just so happens that triangle XPC is also a right angle triangle, so we can apply regular right angle trigonometry for this part also. So to find the bearing of C from X, we need to find this angle here, which I've labelled with theta, and we add that to 180 degrees to give us the bearing that we want. But first, to find angle theta. Now, I've let theta equal angle PXC, so that's here, and XP is equal to 7.5 kilometres that we found in part A. So going back to our triangle, so we have a right angle triangle, hypotenuse 40, the adjacent side 7.5, and again we can apply the cosine ratio to find the value of this angle theta. So cos theta is equal to adjacent over hypotenuse, or 7.5 divided by 40, making theta the subject by taking inverse cos of both sides, or moving the cos over to the other side and using shift cos on your calculator. So it's this cos with a -1. We have theta is equal to inverse cos of 7.5 divided by 40. And that evaluates to 79.193 degrees, correct to 3 decimal places. Now the question is asking for the bearing, correct to the nearest degree. So to get the bearing of C from X, we take 180 degrees, so back to our diagram, that's 180 degrees, add that on to the value of theta that we just found, which is 79.193, and we get 259.193 degrees, which is 259 degrees, correct to the nearest degree. Question 28. A plumber leases equipment which is valued at $60,000. The salvage value of the equipment at any time can be calculated using either of the two methods of depreciation shown in the table. Under which method of depreciation would the salvage value of the equipment be lower at the end of 3 years? Justify your answer with appropriate mathematical calculations. Using the straight line method of depreciation, the salvage value after 3 years is found by taking the original value of the equipment and then subtracting from that 3 years worth of depreciation, where it's depreciating at $3,500 per year. So $60,000 minus $3,500 per year times 3 years is equal to $49,500. Using the declining balance method, the salvage value of the equipment after 3 years is given by 60,000, so that's the original value of the equipment, multiplied by 1 minus 12% in brackets to the power of 3. And that gives us $40,888.32. Therefore, the salvage value will be lower using declining balance method after 3 years by $8,611.68 compared to using the straight line method. Question 29. The table shows monthly repayments for each $1,000 borrowed. Part A. A couple borrows $520,000 to buy a house at 8% per annum over 25 years. How much does the couple repay in total for this loan? The first thing we need to do is to identify the correct factor from the table. Looking at the information presented in Part A, the interest rate per annum is 8%, which means referencing this row here, and it's over a period of 25 years, which means referencing this column here. And the intersection of this row and this column is this value here, 7.72. So that's the factor that I've written down here. The next step is to determine the monthly repayment. So if we go back to the beginning, the table shows the monthly repayments for each $1,000 borrowed. So the question is, how many lots of $1,000 is in $520,000? In fact, if we just scratch out these 3 zeros here, we have 520 lots of 1,000. So the monthly repayment is worked out by 520 lots of 1,000 times the factor that we found previously, so times 7.72, and that equals $4,014.40. The final step is to work out the total repayments. So that's the monthly repayment, $4,014.40, multiplied by 12 months in a year, or 12 repayments in 1 year, multiplied by 25 years. And that gives us $1,204,320. Part B. Chris borrows some money at 7% per annum. Chris will repay the loan over 15 years, paying $3,596 per month. How much money does Chris borrow? First things first, we need to work out the correct factor to use from the table, given the information in Part B. So the interest rate per annum is 7%, and it's over a period of 15 years. Going back to the table, that means referencing this row here and this column here. And the intersection of that row and column is this value here, 8.99. So basically what we're doing is reversing the process that we used in Part A. So the principal, or the amount borrowed, is the monthly repayment divided by the factor that we just found. So $3,596 divided by 8.99, that gives us how many lots of $1,000 that was borrowed. So we need to multiply that by 1,000 to give us the actual amount, which is $400,000. Question 30. A receipt from a supermarket shows a total of $124.87. The GST shown on the receipt is $3.86. GST at a rate of 10% is only charged on some items. What was the value of the items which did not have GST charged? The selling price of items that had GST charged is given by 3.86 divided by 10% plus 3.86, which equals $42.46. That is, the GST component, dividing that by 10% and then adding on the GST gives us the selling price of the items that had GST charged. Now, to find the value of items that did not have GST charged, that's given by $124.87, which is from this value here, and we take away the selling price of the items that had GST charged, and that gives us $82.41. As a side note, the GST is found by taking the item's value and multiplying that by the GST rate of 10%. So to get the item value given the GST, we rearrange this equation to make item value the subject. So item value is equal to GST divided by 10%. And that was the formula that I used here. So to get the selling price, we take the item value that we just found and then add on the GST charged. Question 31. A function center employs staff so that all necessary tasks can be completed between the end of one function and the beginning of the next function. The network diagram shows the time taken in hours for the tasks that need to be completed. Part A. Find the two critical paths. In order to find the critical paths, we need to identify the tasks that have zero float time. In other words, the tasks that must start on time in order to finish within a certain period of time. So we're going to use critical path analysis. That means finding the earliest start time and the latest start time of each task. I'm going to go through this briefly. Now notice that there's two numbers before and after each task. The top number is the earliest start time of that task and the bottom number is the latest start time. So that's EST and LST. So for task A takes 6 hours. So starting at 0, adding 6, we get 6. Task D, starting at 0, it takes 4 hours, so it finishes at 4. Let's look at task E. Starting at 4, adding 2 hours, we also get to 6. Now notice that there's two ways to get to this vertex here. And the higher of the two numbers when finding the earliest start time goes here. So it just so happens that it takes 6 hours to get here, 6 hours to also get here. So that's why there's a 6 here. Moving on, if we look at task B, starting at 6, adding 4 hours, that equals 10. But notice that I've got a 13 here. That's because there's another way to get to this vertex here. Let's go back to vertex F. Starting at 4, adding 2, we get to 6. Notice that there's a 9 here because there's another way to get to this vertex also. Let's look at task H. Starting at 0, adding 2 hours, we get to 2 hours here. 2 plus 7 gives us 9, and that's why there's a 9 here. So look at task G. 9 plus 4 gives us 13. Let's look at task C. 13 plus 4 gives us 17. Let's look at task J. 2 plus 12 gives us 14. 17 is the higher of the two numbers, which is why the 17 goes here for the EST. Let's do the backward scanning. So that's why we have the bottom number here. So starting at 17 and working backwards, 17 minus 4 gives us 13. 17 minus 8 gives us 9. Now 17 minus 12 gives us 5. But we have a 2 here. I'll show you how this 2 arises. 17 minus 8 gives us 9. 9 minus 7 gives us 2. It's the lower of the two numbers that goes on the bottom here for the latest start time. So continuing on, we end up with these ESTs and LSTs as shown for all these tasks. So let's determine the float time of each task. If we look at task J, 17, so take the LST after the task, subtract the time that the task takes, so 17 minus 12, then subtract the EST before that task. So 17 minus 12 minus 2 gives us a float time of 3. So J is not on the critical path. Let's look at K. 17, so LST minus the activity time, minus 8, minus 9 gives us 0. So K is on a critical path. So I'm just going to mark that with a highlighter. If you can see that, I might use a different color, I might use green. Yeah, that's easier to see. Okay, let's have a look at task I. So 9 minus 7 minus 2 also gives us a float time of 0. So this task is also on a critical path. Let's try one more. Let's look at task B, 13 minus 4 minus 6 gives us a float time of 3. So task B is not on a critical path. And I've marked the rest accordingly. So just continuing on the same way, we end up with these float times that I've marked next to each of these tasks. And so the two critical paths are H, I, and K. So that's this task here, this task here, and this task here. And HIGC. So I'll try and use the yellow highlighter again, make that a little bit more prominent. So H, I, G, and C. And the length of both of those critical paths is 17 hours. Part B. The function center wants to decrease the length of each critical path by 3 hours. They can do this by hiring more staff to do one of the tasks so that it takes less time to complete. For which task should the center hire more staff, and how long should that task take to ensure all tasks can be completed in 14 hours? We need to identify one task on the critical paths that we found in Part A in order to reduce the total activity time by 3 hours. In other words, rather than finishing at 17 hours, we finish in 14 hours. So if we look at both critical paths that we found in Part A, we have H, I, and K, and we have H, I, G, and C. What we do notice is that H and I are common tasks on both of those critical paths. In other words, if we chose, let's say, activity G and reduced that by 3 hours, that's all well and good for the critical path that's marked in yellow, but the critical path that's marked in green will still take 17 hours, so that does not help our cause. And for the same reason, activity C cannot be reduced because it does not affect the critical path that's marked in green. We have to choose either activity H or activity I to reduce, and it can only be one or the other. Can't be a combination of both. So if we choose activity H, well, it's 2 hours already. We cannot reduce that by 3 hours. In other words, if we do that, it'll take -1 hours, which doesn't make any sense. So the only task left that we could choose that would reduce both critical paths by 3 hours is activity I, or task I. In my answer, this is what I wrote as my sample solution. H, I are common tasks on both critical paths. H cannot be reduced by 3 hours since it is already 2 hours. And only task I can be reduced by 3 hours, and its activity time will be 7 minus 3, which equals 4 hours. Question 32. Ali has a credit card which has no interest-free period. Interest is charged at 13.5% per annum, compounding daily on the amount owing. During the month, Ali made only one purchase of $450 using the credit card. The full amount owing was repaid 21 days later. Part A. Calculate the amount of interest charged on the purchase, assuming that interest is charged for the 21 days. It's given in the question that the interest is compounding daily, but the interest rate is quoted as 13.5% per annum or per year. Now we're assuming 365 days in a year. And since we're working in days, not in years, we need to work out the daily interest rate. So we start off with the yearly interest rate, 13.5%. and we divide that by the number of days assumed in a year. So we don't count the leap year, we just assume there are 365 days in a year. So the daily interest rate is 13.5% per annum divided by the number of days in a year, which is 365. So I've kept it in exact form. I'm not going to round it. I'll do all the rounding at the very end. So to work out the interest charged on the purchase of $450, we treat the $450 as the principal or the present value. And using the future value formula or the compound interest formula, the interest charged is equal to 450, so that's the principal or the present value, times 1 plus 13.5% over 365 in brackets to the power of 21. That gives you the total amount to be repaid. That is the interest plus the purchase. So we need to subtract from that the purchase or the purchase value of $450. And that gives us 3.50816 and so on, but we need to round that to the nearest cent. So the interest charged is $3.51. Part B. What percentage of the full amount repaid is the interest? Give the answer to 2 decimal places. The full amount repaid is $450, so that's the purchase price, plus the interest charged, which we worked out in Part A, of $3.51, and that gives us $453.51 in total to be repaid. So to work out the percentage of the full amount that is repaid in interest, we take the interest charged, divide that by the full amount to be repaid, and then multiply that by 100 to convert that into a percentage. So that equals 0.7739 and so on percent. But the question is asking us to give the answer to 2 decimal places. So rounding this value here to 2 decimal places, we get 0.77%. Question 33. The diagram shows a shape APQBCD. The shape consists of a rectangle ABCD with an arc PQ on side AB and with side lengths BC equals 3.6 meters and CD equals 8.0 meters. The arc PQ is an arc of a circle with center O and radius 2.1 meters and angle POQ equals 110 degrees. What is the perimeter of the shape APQBCD? Give your answer correct to 1 decimal place. The question is asking for the perimeter of this composite shape, starting from A along to P and then along arc length PQ, and then from Q to B, B to C, C to D, and then D back to A. So in effect, we have a rectangle with a piece cut out, that's the dotted line PQ, replaced with arc PQ. So the strategy is to start off with the perimeter of the rectangle, take away the straight side PQ, and then add on arc length PQ. So let's focus on this triangle here, OPQ. Now, OQ and OP are identical since they are radii of the same circle. So that's 2.1 meters there and 2.1 meters there. And we have an included angle of 110 degrees. So using the cosine rule, we can find the length of straight side PQ. So PQ squared is equal to 2.1 squared plus 2.1 squared minus 2 times 2.1 times 2.1 times cos of 110 degrees. Make sure your calculator is set to degrees and not radians. And that equals 11.83661766. Taking the square root of this value to get the length PQ. we get 3.440438586 meters. I'll do all the rounding at the very end. Now to find the length of arc PQ, we use the arc length formula. That is theta over 360 times 2 times pi times the radius. So 110 over 360, since there are 360 degrees in a full circle. So this gives us the fraction of the full circle that is represented by arc PQ. Multiply that by 2 times pi times the radius 2.1, and that equals 4.031710572. So to get the perimeter, we find the perimeter of the rectangle first. So that's 2 times 8 plus 2 times 3.6. We subtract length PQ, that's the straight side PQ, and then we add on arc length PQ. And that gives us 23.7912 and so on. And rounding this value to one decimal place, we get the perimeter is 23.8 meters, correct to one decimal place. Question 34. A university uses gas to heat its buildings. Over a period of 10 weekdays during winter, the gas used each day was measured in megawatts, and the average outside temperature each day was recorded in degrees Celsius. Using X as the average daily outside temperature and Y as the total daily gas usage, the equation of the least squares regression line was found. The equation of the regression line predicts that when the temperature is 0 degrees Celsius, the daily gas usage is 236 megawatts. The 10 temperatures measured were 0 degrees, 0 degrees, 0 degrees, 2 degrees, 5 degrees, 7 degrees, 8 degrees, 9 degrees, 9 degrees, and 10 degrees. The total gas usage for the 10 weekdays was 1,840 megawatts. In any bivariate dataset, the least squares regression line passes through the point x bar, y bar, where x bar is the sample mean of the x values and y bar is the sample mean of the y values. Part A. Using the information provided, plot the point x bar, y bar and the y-intercept of the least squares regression line on the grid. The first thing I found was the value of x bar, which represents the average of the 10 temperatures recorded. Now here are the 10 temperatures recorded. Either use the stat mode on your calculator or just add the 10 values together and divide by the number of values, which is 10. So adding these values together, we get 50. Dividing 50 by 10, we get 5. So x bar is equal to 5. Next, find the value of y bar. Now, y bar represents the average of the gas usage over the 10 weekdays. And the clue to work that out is found in this line here. So the total gas usage, in other words, the sum of the scores, is 1,840 over the 10 weekdays. And there were 10 measurements that were taken. We don't know the individual measurements. What we do know though is the sum of those measurements. So taking the sum of the scores and dividing it again by the number of scores, which is 10, y bar is equal to 1,840 divided by 10, which gives us 184. The final step is to find the y-intercept. And the clue is given in this sentence here. So the equation of the regression line predicts that when the temperature is 0 degrees Celsius, in other words, that's a value that's on the y-axis, the daily gas usage is 236 megawatts. So we can read this directly as the y-intercept, and I've noted that here. So the y-intercept is 236. Now we can take this information and plot those points on the grid. So I plotted the y-intercept here, just taking note that every square vertically represents 2 megawatts. So there are 5 divisions there from 230 to 240, so 236 is just there. And the point x bar comma y bar is this point here. Part B. What is the equation of the regression line? To work out the equation of the least squares regression line, we need 2 bits of information. We need the gradient of the line. We also need the y-intercept. Now the y-intercept is already given, so we don't need to work that out. We just need to make sure that that's incorporated in our final answer. Now to work out the gradient of the line, there's one of 2 methods. Either we can just draw a triangle, work out the rise, work out the run, and gradient equals rise over run, noting that it's a downhill or a downward sloping line, so the gradient will be negative, or we can use the 2-point gradient formula. In my solution, I'm going to use the 2-point gradient formula. And this is the point x1, y1, this is the point x2, y2. So using the 2-point formula, the gradient m is equal to y2 minus y1 in brackets, so that represents the rise, divided by x2 minus x1, which represents the run. And substituting the respective values for y2, y1, x2, x1, we get gradient m is equal to 184 minus 236 in brackets, divided by 5 minus 0. And that evaluates to negative 10.4. So putting that all together, now that we know the gradient and we know the y-intercept, putting it in the form y equals mx plus c, the equation of the regression line is y equals negative 10.4x plus 236. Part C. In the context of the dataset, identify one problem with using the regression line to predict gas usage when the average outside temperature is 23 degrees Celsius. The question is asking us to identify one problem or issue using the regression line to predict gas usage. In this sample solution, I've given 2 problems or 2 issues that I've identified. There may be others, but I'm going to go through these 2 issues one at a time. Firstly, when x equals 23, using the equation of the regression line that we found in part B, we find that the y value, which represents gas usage, is negative 3.2. And that's a nonsense answer. It's invalid since gas usage cannot be negative. It cannot be less than 0. The other reason is that extrapolation beyond the range of data is unreliable, as it cannot be assumed that the model remains linear outside the range of values given. Question 35. The diagram shows triangle ABC. Calculate the area of the triangle to the nearest square metre. Analysing the diagram provided, we have a non-right angle triangle for starters. We have one of the sides known. We have a couple of known angles, but the height is not directly known. So that's a clue that we may need to use the formula half times A times B times sine of angle C in order to work out the area of this triangle. But in order to do that, we need two known sides and an included angle. And the included angle is the angle in between the two known sides. So our first issue is to find the value of this unknown angle here, and I've marked that with the angle theta. And then once we've got that, we need to find another side, and I've marked the side that I want to find with the variable x. So let's find the value of theta. So using the angle sum of a triangle property, in other words, all angles add up to 180 degrees in any triangle, theta is equal to 180 degrees minus 60 degrees minus 25 degrees, and that gives us 95 degrees. So this angle here is 95. The next thing we need to find is the value of this variable x, which represents the length of side BC of this triangle. So I'm going to use the sine rule here because I have a known side angle pair. So we've got 12 meters and its opposite angle is 25 degrees, so they're both known. Because we have a known side angle pair, it makes using the sine rule possible. So using the sine rule, x divided by or over sine 60 degrees is equal to 12 divided by sine 25 degrees. And I've set this up as an equation. So rather than writing it in fraction form, I've used the division symbol instead. Just makes it a little bit easier to write on these lines. Rearranging the equation to make x the subject, x is being divided by sine 60 degrees. If we move that over to the other side, it becomes a multiplication. So x is equal to 12 divided by sine 25 degrees times sine of 60 degrees. And that evaluates to 24.59028818 meters. I'll do all the rounding at the very end. Now to find the area of this triangle. We have two known sides and an included angle. So using the half AB sine C formula, area is equal to half times 12 times 24.59028818 times sine of 95 degrees. And that evaluates to 146.98 and so on. But the question is asking for the area correct to the nearest square meter. So rounding this value here to the nearest whole number or to the nearest square meter, we get 147 square meters. Question 36. The following formula can be used to calculate an estimate for blood alcohol content, BAC, for males. BAC male equals 10N minus 7.5H over 6.8M. N is the number of standard drinks consumed. M is the person's weight in kilograms. H is the number of hours of drinking. Cameron weighs 75 kilograms. His BAC was 0 when he began drinking alcohol. At 9 p.m, after consuming 3 standard drinks, his BAC was 0.02. Using the formula, estimate at what time Cameron began drinking alcohol to the nearest minute. The strategy is to rearrange this formula to make H the subject. Since H represents the number of hours that Cameron has been drinking, once we work out the value of H, we can subtract that from 9 p.m. to get the approximate time that Cameron began drinking alcohol. Now, we know some values already. We know that Cameron's BAC is 0.02 at 9 p.m. We know how many standard drinks he consumed, which is 3. We also know his weight, which is 75 kilograms. So substituting 0.02 for BAC, 3 for N and 75 for M, we can rewrite the formula using the division symbol here. And I've used this format as I find it a little bit easier to write it in this form given the lines that are provided. Note though that to write an equation that's originally in fraction form using the division symbol, that you must use brackets around the numerator and the denominator, or else you'll get an incorrect answer. So 0.02 is equal to 10 times 3 minus 7.5 times h in brackets divided by 6.8 times 75 in brackets. So I've evaluated 10 times 3 here and 6.8 times 75 here. So the equation can be written in a more simplified form. 0.02 equals 30 minus 7.5 times h in brackets divided by 510. Now we can start the process of reversing or rearranging this formula to make h the subject. So multiplying both sides of the equation by 510, since multiplication is the opposite of division, we get 10.2 is equal to 30 minus 7.5 times h. Now, since negatives can be problematic, and also we want h ideally to be on the left-hand side of the equation, what I've done here is I've added 7.5 times h to both sides of the equation, which effectively cancels this negative 7.5 times h here, moves it over to the other side, and it becomes a positive, which is more ideal. So the equation is 7.5 times h plus 10.2 is equal to 30. Subtracting 10.2 from both sides of the equation, we get 7.5 times h is equal to 19.8. And finally, dividing both sides of the equation by 7.5, we get h is equal to 19.8 divided by 7.5, which equals 2.64 hours. And using the degrees, minutes, seconds button on the calculator, which is this button here, or wherever you find that function on the model of calculator that you're using, 2.64 hours is equivalent to 2 hours, 38 minutes, and 24 seconds. Now, whichever method you'd like to use at this point to subtract 2 hours, 38 minutes, 24 seconds from 9 p.m. to find the start time when Cameron began drinking alcohol, I've converted 9 p.m. to 24-hour time. So 9 p.m. is 2100 hours. And using the degrees, minutes, seconds button on the calculator, 2100 hours minus 2 hours, 38 minutes, 24 seconds is equal to 18:21:36. So 18 hours, 21 minutes, 36 seconds. So that's in the evening. Or in 12-hour time, that's 6:21 p.m. and 36 seconds. So rounding this time, correct to the nearest minute, the 21 gets rounded up to a 22. So Cameron started drinking at 6:22 p.m. Question 37. The table shows personal income tax rates for different taxable incomes for a particular country. A person with a taxable income of $90,000 pays 25.8% of that income in tax, excluding any levies. What is the value of X in the table? My first calculation is to work out the tax paid on this taxable income of $90,000. Now, it's given in the question that 25.8% of $90,000 is paid in tax, so that's a simple enough calculation. The tax paid is $90,000 times 25.8%, which equals $23,220. Now, the next part of the solution is to model the rule in this row, 18,292 plus X cents for each dollar over $78,800, using an equation and then solving that equation for X. So the equation I'm going to use to model the rule is 23,220, which represents the amount of tax paid on this taxable income, and that equals $18,292, which is from this value here, plus x over 100. Now, this part of the rule here, x cents for each dollar, can be interpreted as a percentage. In other words, you can think of it as x percent of each dollar over $78,800. So the way I've represented that is x over 100 times the difference between $90,000 and $78,800. This gives us the amount over $78,800, which is this part of the rule here. So going back over this again, the equation is 23,220 is equal to 18,292 plus x over 100 times 90,000 minus 78,800 in brackets. Now we need to solve the equation for x. So one thing I've done is I've subtracted 18,292 from both sides of the equation, and I've also evaluated what's in brackets here. I've done that in one step. So doing the subtraction here and here, the equation simplifies to 4,928 is equal to x over 100 times 11,200. Now, the right-hand side of the equation simplifies. We can cross off these two zeros here and these two zeros here. So the equation becomes 4,928 is equal to x times 112. Finally, to make x the subject, we can divide both sides of the equation by 112. So x is equal to 4,928 divided by 112. Therefore, x is equal to 44. Question 38. A random variable is normally distributed with a mean of 0 and a standard deviation of 1. The table gives the probability that this random variable lies below z for some positive values of z. The probability values given in the table are represented by the shaded area in the following diagram. The weights of adult male koalas form a normal distribution with mean mu equals 10.40 kilograms and standard deviation sigma equals 1.15 kilograms. In a group of 400 adult male koalas, how many would be expected to weigh more than 11.93 kilograms? The strategy is to work out the percentage of scores that's represented by the unshaded region in this diagram. Now, the shaded region in the diagram gives us the percentage of scores that lie below Z, and they're given in this table of Z scores. However, the question is asking for the number of male koalas that lie above a certain score, not below. But the first thing we need to do is to work out what the corresponding Z score is for this raw or actual score of 11.93 kilograms. Then we can proceed to find this percentage that's represented by the unshaded region, or the percentage that lies above Z. So using the Z score formula, that is raw score minus mu divided by the standard deviation, we have Z is equal to 11.93 minus 10.4 in brackets divided by 1.15, and that equals 1.33, correct to 2 decimal places. Now, using the table of Z scores, the percentage or proportion of scores that lie below Z equals 1.33, so that's this value here, is 0.9082 or 90.82%. But we want the percentage of scores that lie above Z equal 1.33. And that's found by 100% minus 90.82%, since 100% of scores are contained in the normal distribution. So really what we're doing is finding the complement of 90.82%, and that's 9.18%. So in other words, 9.18% of koalas will have a mass or a weight greater than 11.93 kilograms. So the expected frequency of koalas weighing more than 11.93 kilograms, which corresponds to a Z-score of 1.33, is found by taking 400, which is the sample of adult male koalas, and multiplying that by 9.18%, and that equals 36.72. So I'm going to ignore the decimal component of this answer since I'm interested in the number of whole koalas. Therefore, 36 koalas out of 400 are expected to weigh more than 11.93 kilograms.